Let's talk a little bit about an old friend that is in the group known as motors with pistons. Alternative engines, particularly in this case, the diesel engine. The diesel engine is always under immense pressure. I always go back to the analogy of the bicycle. Between the bike and the bike pedal, the piston is something like your foot pushing down on the bike pedal. And the pedal is like the connecting rod, and then comes the transmission and so on. The force that is being applied to the piston is very, very, very important. Let's begin by looking at the cycles of the engine. The cycle of intake, the cycle of compression, the cycle of combustion, and the cycle of exhaust. If we relate how the piston is rotating through the up and down positions and what the temperatures are, they can get up to 2000 degrees Fahrenheit. It is astounding. And the head of the piston can get up to 350 degrees Fahrenheit. With that much heat, there needs to be a way to cool the head down so everything does not melt. Around 98% of these heads are made from aluminum, so they have to be cooled down. And in this step 2, here it is explained that one of the many contaminants that are mentioned, particularly the nitrogen oxides, which are a product of the fact that at 2000 degrees Celsius, the air burns itself, the 78% nitrogen oxidizes with the 21% oxygen, and they form nitrogen oxide, which is extremely toxic. And you have to start adding ammonia at the Euro 5 or Euro 6 standards to try and mediate it. But let's move forward with this. If you look closely, you see that pistons generally have 3 rings, which are located at the head of the piston. The lowest of the 3 is known as the oil scraper, whose job it is to eliminate the most oil it can, so that oil does not reach the combustion area and burn up. We want the oil there for lubrication, not for burning. But there's always some that gets through, so the middle ring is also there to get the leftover, although it's also known as the compression ring. That also controls the oil from reaching the top. The uppermost ring is really the one that acts as a compression ring. Its function is to seal in such a way that the gases produced by the combustion don't escape and go towards the crankcase, but that they take care of pushing the piston down. Those 3 rings absolutely need to have oil present, otherwise they would end up being generated on. And if we are talking about oil in the walls of the cylinder, in reality, it is a film about 2 microns thick that takes care of lubricating the piston. As you can see, above the top ring there is practically no oil, and in reality the zone that is above the top ring should never touch the walls of the cylinder. The sheer velocity that the piston is moving at is highly variable. We can go from about 15 feet per second up to about 80 feet per second. Here in this example, at 2000 revolutions per minute, note that the G-force, or the force due to gravitational attraction and the accelerations the piston is going through, it can pull about 70 Gs, but it can at other times be pulling upwards of 1000 Gs. That makes the stresses to which it is subjected, not only the piston, but what holds it, which is the connecting rod, be tremendous. Imagine that the piston is moving upwards at an immense speed, and when it reaches the top, it is slowed to 0, and then the connecting rod tells it to drop instantly. You can imagine the jolt it gives is insane. Therefore, the rod must be very well dimensioned, especially the ones in high performance or competition engines. An interesting question is, how is it cooled? Water doesn't get to it. The cooling circuit doesn't get to it. How is it cooled? With oil. Almost all diesel engines have an oil injector in the base that's connected to the block that injects a stream of oil through an oil cooler duct and goes around the cylinder head and comes back down to the crankcase. The oil here is not functioning as a lubricant, it is doing one of its many duties as a lubricant, which is cooling. In this case in particular, cooling the piston. Our old friend the piston, that if we were to define which parts are the most committed, the most important on an engine, I would tell you that the piston is on the podium, or fighting for the podium, and requires most attention to what it's made of, how it's finished, how it's built. It's quite a compilation from a century ago that billions of engines have pistons that go up and down. If you like this video, like and subscribe today. AutoTechTV, technology clear and simple.